I love how you say that.
Okay. Just like the French.
All right, here we go. Ladies and gentlemen, today we are looking at circular motion today.
No.
So we're talking about linear and angular speed. And so I haven't taught this in many, many moons, but everything looks okay today. I have a lovely prop here. And on this prop, I have a star and I have a heart. And they're racing. And as they're racing, are they going at the same? Are they going at the same speed? Kind of is an interesting answer. Why are they kind of going at the same speed?
They're going different distances. This one's mine. It looks like they're going. No.
Okay. So, gentlemen, stop it. Do I need to separate you?
No, we're trying to figure out what
Cause,
to switch.
okay.
Get both of ours.
All right. You should have your name on it. All right. So, they appear that they're going the same speed. But would you want to run in this race?
No.
No, right? If you're the heart, are you a happy runner? No, right? Why aren't you a happy runner if you're the heart?
Because you're running longer.
You're going further, right?
You have a longer radius.
Yeah. So the heart, and everyone's here, so the video doesn't matter. Yeah, so if you're the person who's the heart, you're running a lot faster than the person on the inside, right? Have you ever played that game where everybody holds hands and like you start running in a circle? Yeah? Yeah, what happens to the person on the end every single time? Yeah, they get flung, right? Because they have to run so much faster to keep up with everybody. This is the difference between linear speed and angular speed, okay? The heart and the star are moving at the same angular speed. They're sweeping out an angle that matches all the way around, okay? So their angular speed is the same. However, their linear speed, if you were to imagine that heart wasn't bounded by moving only in a circle. The linear speed, the distance that heart is traveling is much further than the distance the little star is traveling. So this heart is moving faster. His speed is faster because he's going further in the same amount of time. Okay? And this is the difference between angular speed, where the angle is the same for them, versus the line that they're running. That straight line motion is much faster. Okay? So they have the same angular speed, but a different linear speed. So arc lengths can be used to analyze circular motion. Thus, this is called circular motion. So suppose an object moves along a circular path. And so we have a circle here. And S is what we were talking about yesterday. The S is the arc length. And it's a length, meaning it's a distance. All right? So we can figure out how long that distance is. And it has a radius of r here, so that's really good. If we want to find the rate at which an object moves along its path, it's called linear speed, or V for velocity. And if I want to know velocity, velocity is like we're driving a car, right? We're driving a car, M66, the speed is 55 miles per hour. Miles is a distance. Per hour is time. So it is the distance over the time that we're traveling. Is that someone's folder? Yeah. Oh, is it a sticker that has this on there? That's very funny. This is the Velociraptor. It's the distance raptor over the time raptor. Distance over time is Velociraptor. That's funny. Okay, that's pretty good. All right. All right. Funny. Okay, so I love that. That is great. You made my day. Well, thanks. All right. I have my own sticker. Yeah, I I didn't read through all the stickers, so they came in a bundle. It's distance over time. Well, the distance that our particle, or maybe the heart on my circle here, the distance that it's traveling is the arc length s over our time t. So this s represents the arc length, which is really just the part of the circumference. Okay? But I really just think about it in terms of the distance my particle is traveling, so we'll talk more about that. Now, the rate at which the central angle is theta right here. So we have our little central angle, theta. The rate at which the central angle is changing along a path is called angular speed. And again, angular speed uses this letter. It looks like a curly W. That is the Greek letter omega. It's lowercase. Greek letter omega. And if I want angular speed, so angular speed, again, its speed is a distance over time, but angular speed is the angle that we're sweeping out over time, t. And that is the central angle. Central angle, whatever, however many radians, if you will. Okay, so we're going to try some here. We have, for questions 1 and 2, a bicycle tire with a radius of 14 inches. So I'm going to just draw a picture because I think a picture is super important. So here's my little bicycle tire. It has a radius of 14 inches. So here's my radius of 14 inches. And it rotates at a rate of 125 revolutions per minute. So that's RPMs, is revolutions per minute. And we want to find the linear speed of the tire in inches per minute. So that's what we're looking for, inches per minute. So you have to imagine here, I am right here. I've got a spot on my tire, the very end of the tire, and it's traveling. It's rotating around my tire. How far did it travel if it just went one time? What? Say it out loud again.
Diameter times pi, 28 times pi.
Oh, okay. So you're saying circumference is 2 pi r or pi d. And so in one rotation, it traveled, let's see, so I like to try and find the distance that it's going, okay? So in one rotation, it traveled one circumference, right? So that would be 2 times pi times my radius of 14 inches. But that was only one rotation, right? But how many rotations did it do? Yeah, it's going to do 125 rotations per minute. So we're going to, that's one rotation is one circumference, but it's doing a whole lot more than that, right? So we're going to multiply that by 125 rotations per minute. And that's going to give me the total distance that that little particle, that little dot on my tire traveled. It's a long way. So in my calculator, let's see, I'm just going to leave it in terms of pi. So 2 times 14 times 125, I get 3,500. The unit on top is inches in 1 minute of revolutions. Okay? So the distance that little thing traveled was 3,500 pi inches per minute. Okay, now when we put that per minute on there, we've got time on the bottom. So that is our velocity. So the velocity turns out to be that 3,500 pi inches per 1 minute. And I can put that in my calculator to get an approximation here. 3,500 times pi turns out to be 10,995.6 inches per minute. So velocity is distance over time, and finding the distance, I think, is the hardest part. All right. So in 1 minute, it went almost 11,000 inches. That's a lot. Okay. Now, if we want to find the angular speed, the angular speed is the central angle that it's sweeping out. And so when we have each rotation or each revolution has a circumference of 2 pi r, and the central angle is 2 pi radians. If we do one rotation, what was our central angle? How much did we rotate? 360 degrees, but how many radians? 2 pi. So theta is 2 pi, but that's just one rotation. So if I want to figure out my theta, one rotation is 2 pi. That's one full rotation. But how many rotations did this tire make? It made 125 rotations. So we get 250 pi for the total angles that we're spinning out here, all the angle rotations. To get the angular speed, it is theta over our time, which was 250 pi radians over 1 minute that we were told we went. Which 250 pi divided by 250 pi divided by 1 is 785.4 radians per 1 minute. All right, let's try another one because these are a little bit weird to get your mind around here. Okay, so now for 3 and 4, a CD with a diameter of 120 millimeters, so that's a diameter. So again, I'm going to draw a picture. I have a CD. Oh my God, have you guys used a CD before? Yeah. Oh, that's good. Let's just checking. It has a diameter of 120 millimeters. What's the radius? 60 millimeters. Okay, 60 millimeters is our radius. And it rotates at a rate of 45 revolutions per minute. So we want to find the linear speed. The velocity is distance over time. All right, so let's see what we got. The distance. So imagine I am a speck on the end of my CD player, and if I am traveling a distance around the edge of my, all right, 2 pi r.
I see my record from this morning.
Oh, great. Good job. Yay, way to go. All right. So we did one rotation is 2 times pi times my radius of 60 millimeters. But did we go just one loop around? Times 45 rotations per 1 minute. And so I can plug that all into my calculator. So 2 times pi times 60 times 45 is 16,964.6. 16,964.6 millimeters per minute, per 1 minute.
No.
I don't know.
Yeah. Like really.
Well, is it 1,000 or I guess it'd be 1,000 millimeters is one meter?
16 meters.
16 meters? No, it's not.
600
The hallway here. Yeah.
667.
All right. Let's look at the angular speed. Angular speed is the angle that we're sweeping out per time. So let's figure out our angle that we're sweeping out. So again, if my CD is rotating, what's the angle we sweep out for one rotation? 2 pi. Yep. So the one angle that we sweep out is 2 pi, but we don't just do it the one time. How many times are we sweeping that angle out? Yeah, we're sweeping it out 45 times. 2 pi radians per 1 minute. All right, so time on the bottom there. All right, so 2 times pi times 45 turns out to be 282.7 radians per minute. All right, are you okay with that? Okay, it's not too bad? All right, so then here's where this... Number 5. Number 5. A 16-inch diameter tire on a car. 16-inch diameter. So again, I'm just going to make a little picture over here. 8-inch radius, okay, on a car is making 500 revolutions per minute. We want to find the linear speed in miles per hour. So we have some unit conversions we're going to end up doing, but I'm going to hold off before I do that. So first, I want to find my linear speed, which is the distance traveled over time. So let's think about my spot on the end of my tire here. If it's traveling around in a circle, what's one rotation of distance? 2 times pi times 8 inches. And I'm making sure I put my units on. That's really important. But that's just one rotation. How many rotations are we doing? 500. So 500 rotations per 1 minute. All right, so again with my units, I want to make sure I have units so I can convert nicely here. All right, so let's see, 2 times pi times 8 times 500, and I get 25,132.7 inches per minute. But I need miles per hour. All right, so here we go. I'm going to take my 25,132.7 inches per minute, and we're going to do a lot of conversions here. So let's start. We need to turn, I guess, minutes. We can try to turn into hours. So let's see. What do we know about minutes? 60 minutes is 1 hour. All right. All right. So 60 minutes, why am I putting the minutes on top? Yeah, because I want my minutes to cancel out. So when I have 60 minutes is the same as 1 hour, I want the minutes on top because minutes on top is going to cancel with my minutes on the bottom. Okay? So now I have hours on the bottom. That's good. Let's see. What about inches? What do we know about inches? 1 foot is 12 inches. Okay. So I want inches on the bottom. 12 inches on the bottom is the same as 1 foot. Why did I put inches on the bottom? So they cancel out. Inches on top cancels with inches on the bottom. Now I've got feet. I still am trying to get to miles. So I have to multiply again. Tell me what you know about miles. 5,280. 5,280 feet is 1 mile. Why did I put feet on the bottom? So it cancels with the feet on the top. Feet on top cancel with feet on the bottom, and we're left with miles on top, which is what we want. Straight across, yes, multiply straight across. So I'm going to take my answer that I already have in my calculator. I need to times it by 60. And then, oh, let's see. It's not just 5280. All right, so I get 1507964.4 over 12 times 5, 5280. 12 times 5280. 63,360. Oh my goodness. All right, so now I've got my big 1.5 million there. I'm going to take that and divide it by 63,360. And I get 23.8. And my units are, the only units left on the top are miles, and the only units left on the bottom are hours. All right. You remember this from physics? Oh, yeah. So hopefully your problems aren't too terrible today, but so that's not too bad. A lot of conversion. Let's turn the page. All right. As we were doing this, did one of these feel easier to do than the other, or are they about the same to you? About the same?
The one on the left is easier, like linear speed, I think.
Well, so we're more familiar with linear speed, so I think it just, you understand it a little bit better instead of thinking about the angle that we're sweeping out as we move. But in terms of like calculations, the angular actually is a little bit easier to do.
Yeah.
All right, so angular speed, using angular speed to find linear speed. Now we have an option. Linear speed can also be found as follows. We know that linear speed was the distance over time. Our distance was really arc length that we were doing. Okay, arc length over time. And because we did arc length we know from our work the day before, arc length is the radius times S equals R theta. Do you remember that equation, S equals R theta? Okay. So S equals R theta was our arc length equation. But then, that's really, we have the radius times theta over time. Well, theta over time is what we just did. The angle that we sweep out over a certain amount of time is just angular speed. So that is radius times omega. So if we can figure out our angular speed, to figure out linear speed, all I have to do is multiply by the radius. And that'll give us the linear speed, which is kind of nice. So let's look and try a couple of those so you can see. A ceiling fan with a 25-inch blade. So here's my ceiling fan. All right, we got a ceiling fan. Yeah, it looks something like that. We're gonna pretend, ladies and gentlemen. Okay. Oh, it's sort of Pac-Man there. Okay. It's got a 25-inch blade. All right, and it rotates at 40 rotations per minute. Find the linear speed. So our goal is linear speed in feet per second. All right. We're going to start by trying to find the angular speed. So again, when I think about angular speed, I'm thinking about my central angle that's spinning around. One rotation, what's the angle for one rotation all the way around? 2 pi, yep. 2 pi radians. All right. And how many rotations are we doing here? 40 rotations per minute. And so we get 80 pi radians, R-A-D-S, radians per minute for our angular speed. Now, if I want velocity, velocity is just radius times omega. Radius times our angular speed. What's our radius here? 25 inches. And our angular speed was 80 pi radians per minute. And if I multiply those together, 25, oh my goodness, 25 times 80 pi. (6283.2-ish). What are the units on this linear speed? Inches on top and minutes on the bottom. All right, and is that what we want? No, we want to do in feet per second here. So more conversions. All right, in feet per second. So I'm going to take my 6283.2 inches on top, minutes on the bottom, and I need to convert to feet and seconds.
60 on top.
Okay, so 60 second, no, not 60 on top. Tell me what you know about seconds. 60 seconds is the same as 1 minute. So 1 minute on top has 60 seconds on the bottom. I need minutes to cancel out with minutes, so my minutes needed to be on top. All right, I got seconds. Now, tell me what you know about feet. 12 inches equals 1 foot. All right, I have inches on top, so I want inches on the bottom to cancel out, and that is the same as 1 foot. So inches on top and inches on bottom cancel out, leaving feet on top. All right. Oh, man, I wanted that answer. There we go. So I have my 6283.2 feet on top, and on the bottom, I've got to have 60 times 12, which is 720 seconds. All right, so I'm going to take my 6283 divided by 720. Did you divide? 8.7 feet per second. What did you do, Sasha? Did you divide by 60 but then end up multiplying by 12?
Yeah.
Ah.
Yeah.
Yeah, you got to divide by both. Oh, so you know what you could do? You could do your 6283 divided by 60 and then divided again by 12, and then you'll get it, right? Both of those need to divide. Yeah? Okay. Alright. Ryan is riding a bicycle whose wheels are 28 inches in diameter. Um, 28 inches in diameter. What's the radius there? 14. Okay. 14 inches, all right. If the wheels rotate at 130 revolutions per minute, find the linear speed in miles per hour in which he is traveling. So I want to find, using angular speed is the goal here. Angle, the angle that my tire rotates is 2 pi radians. How many times? 130 revolutions or rotations per 1 minute. And that's going to be 260 pi radians per minute. How do I get the linear speed?
By 14.
Multiply by the radius. Radius times our angular speed. So we have radius of 14 inches times our 260 pi radians per minute. All right, so we have 14 times 260 pi, which turns out to be 11435.4 inches per minute. Not too bad. But we want this in linear speed in miles per hour. So I'm going to convert 11435.4 inches on top, minutes on the bottom. All right, I want hours. Tell me what you know about hours and minutes. 60 minutes in an hour. So I want 60 minutes on top, 1 hour on the bottom. So my minutes can cancel. Now tell me what you know about miles. Ooh, anything about stupid American units. Inches?
63,360 inches in a mile.
Oh my God. Help me get there.
There are 12 inches in a feet.
12 inches in 1 foot. Very good. So now my inches are gone. Inches on top, inches on bottom, cancel. And then
5,280.
5,280 feet is the same as 1 mile. Lordy, lordy. All right, so my feet on top and feet on bottom cancel, and I'm left with miles per hour. That's what I want. So the calculator work is the hard part here. I'm going to take my answer. I'm going to multiply by, what's up? Multiply by 60. And I have to divide by 12 and divide by 5280. Because the 12 is on the bottom and the 5280 is on the bottom. And I get 10.8 miles per hour. All right, how do you feel? Is that okay?
Yeah.
All right. The unit conversion is good. All right.
It's horrible. It's really bad.
Worksheet. I think you can handle it. It's just mostly calculator work.
Thank you.
You're welcome.
It actually isn't that bad.
Nope, not that bad. Yeah. Yeah, thank God for calculators, right? I think is really what this is. I tried to use it yesterday. Was it yesterday or the day before? I don't remember. But
slideshow that just
I'm going to create a slideshow for my 8th graders that just has different pictures of angles and like what kind of angles are they? Are they vertical angles? Are they complementary angles? Are they supplementary angles? Just super easy, just like flashcard type of vocabulary sort of things. And do you want to see what ChatGPT gave me?
Yeah.
Oh, I sort of deleted it. Sort of kind of stuff. Hold on.
You can go back.
I'll you can give me decimal answers, it's fine. All right, so here's what ChatGPT gave me. Identify the angle type. So this is, I'm just going to stick down here. There we go. That's what ChatGPT gave me. And those are, what are those? What the hell is that, right? Evidently those are complementary angles. What are those? I thought they were adjacent angles, but those are supplementary angles. Yeah, so this was, this was the fail from ChatGPT. I was like, no. So, that's not that way. All right.
Radians per minute. Do you want me to wait till?
Yeah.
Radians.
Yep.
I see it. I'm gonna wait until it comes back and then I just go first. Did you leave it in cat?
This is what number? 3.
Yeah.
Your turn, let's answer the first one.
42,804.
You got it right.
That's the close.
Nice. I bet Sunny's slower or something.
We're doing all of them, so like it's, the thing is really going like this. You got
Sunny's
be more likely to steal our conferences. How do they find out that?
I don't know.
The big deal.
Circumference?
It's just,
Circumference times the number of rotations. What's the formula for circumference? 2 pi r. Okay. So look at your problem. Make sure you can write down at the top of your page.
You know what, this is my water.
Pi r. C equals 2 pi r. Okay. Alright. So
Yeah.
I'm not kidding.
You never look out the door.
Go out.
That's stupid.
I just don't.
velocity is distance over time. The
What if
distance
we
the thing
go
is traveling, if it only went one
It's
time,
not
it
that
would be
I mean, I understand why.
but it didn't spin once.
Which is why what
It did. 45 rotations. So we have to multiply it by
I'm
that.
not.
That's 135 times that it rotated in the one bit. Multiply straight up.
Yes, because it's more. I thought so. When you're converting down from minutes to seconds would be 1/6. This is
Let's, hold on,
1/67.
let's see. 1 minute and 60 seconds. So just write your units in and it'll go a lot better.
So basically, that just means it has wonderful.
I don't know if anybody wants to show me any worksheets. Like the angles one we did, all the angles.
Wait, do I have any that I'm missing?
I got one.
well, I believe that's the same other than the one.
I have two, well, one I have an 8 and the other one is. One is with
This one's from, I know this
yeah, and
one.
that one was all.
Okay, I'm saying, yeah.
Scott, I don't think angles and then 12. Yeah, that's the angles one right there on top. And then number 12 was the progression. Nope, underneath right there. That's the one we don't have. Have it half done. Right over. Hey! Yeah, I have it on
This first, oh, you missed one. I didn't know how to do that one. That's why it's in the 10.
How do you get what's millimeters to meter?
Millimeters to this. Millimeters to meters.
Degree decimal point.
Yeah.
Yeah, so this is 26 minutes, and I need to convert it into degrees. Well, there were 60 minutes in 1 degree. Okay, so that ends up having to divide. Here, this was 18 seconds. I'm talking about 18 seconds. 1 degree had 100. Okay. And so then you just get to add everything.
That's negative.
So that's the whole part. So it's 58. And then you can add those together. Yeah. Thank you.
Millimeters to meters. Like it's like squeezing my neck too tight.
Karen, why are we on our phones? Karen, get off your phone, Karen.
Oh, okay.
You just opened
Alright.
stuff.
Yeah, yeah. Alright.
Karen, you can chill. So there's someone on that.
Right there.
Completely the same problem. It's okay, dude. Nice, where are you?
Good. Good. Good.
You sound good. So I'm willing to try it. So I always see where you grab it. That's the first one I've ever figured out.
You have any?
He always sees me. I always yell at Kate when I try. Yeah. I never see Cole. Actually, no, I saw you and Tyler
For you, I have an 8
once.
out of 10.
I always get blessed by seeing Cole.
Yeah, I don't know why. It's just every time I decide I want to go to like the store or something. No, I've gone to the gas station so many times and not seen you. But whenever I go past the bridge is whenever I see you.
I never see him. I was one time that he showed up at my doorstep. Compared to disabled takers.
Dude, I've
You see my curtains open? My curtains open. I see you like that. You see my hand going every once in a while.
8 out of 10. Okay.
I've let my friend get
So wait, Mr. Now.
Dude, I've had a friend that's been sitting out of sunlight for like 3 years and it's still alive.
I've had a friend that I haven't watered in like
straight sunlight.
So
It's literally been like, it's like if it's black. Okay, no, it's not. Then it's fine.
Whatever you're
It doesn't have to be like
comfortable with
straight.
this
I haven't watered it in like a year though. Okay, that makes sense.
This one, just asking for ambulance speed.
It's not fake, dude. I haven't watered in a year. And it might have a shriveled thing over it. It's not
I'm trying to
dead.
grow. Well, water it then. Don't let it die.
Did you want it? That's what I have.
Actually, I would take it. I don't want. I want to get plants for my. I've already put two oysters in a flag. So.
You should put it in the French flag.
An old one?
Yep.
I would. If you got me one, I'll be up there for at least a week.
No, the rest.
No.
Is it Elijah?
Why?
Elijah?
Yeah. I don't need them thinking I'm a Nazi. That'd be a little wrong.
But it's like a little size.
Are you gonna look up here?
I actually do too, because it actually looks cool.
Be warned.
Probably fly there. I just have a little tree. Yeah.
No, before a football game, you gotta go home and trim your tree. Like, Coach G, I was late because I had to trim my tree.
I'm floating.
You're late to practice, Coach. I'm trimming my tree.
Yes, that's right.
Millimeters.
It just be the
Many millimeters.
Okay, so the per second. So that's the 1 minute and 52 seconds.
Yeah. Yeah. Yeah.
So, when converting to seconds, would it be like 60? I don't know.
So, so we would have canceled the minutes.
So what
So, yeah. Well, so right now you are in That was 28 millimeters. Okay, so this is millimeters. Right? So we have to convert millimeters.
It's too smart.
Ladies and gentlemen, how many millimeters are in 1 meter? 1,000. So 1,000 millimeters is 1 meter.
I think something happened.
It is.
We are finding linear speed. Yeah, because you speed is over time. So distance over time was 1 minute. 1 second. Just kidding. Revolution per second. Yeah, there you go. Okay.
And then I just go
Linear speed.
Is that fine to do it this way?
It's totally fine. So what you want to do, this is 8 inches. Okay. And so that when you get your answer, you know that you're in inches per second. Because we need to convert. Really, this is an actual way of converting. Oh, okay. Let me check that. Where?
Yeah, he most definitely is.
No, actually, I'm just very thankful.
Where's the word?
And those are the only 2 that you have done.
Why is
How
how much of this do you have done?
What? Show me.
I have just the research. We have a day left. You get another day. Just literally said it. If he did, I was just gaslighting the same thing he said that.
Dude, yeah, okay.
Yeah. Come on, man. You gotta know the program.
On the record. And your angle that you're shooting at and one rotation, what angle did it travel? What angle opened up? So 2 pi radian. Right, we're gonna just do 1 rotation, right? How many rotations did we do? 33. In 1 minute. I finished.
I wrote out something.
Thanks.
Like to get the first one, but I didn't write like the dimension. Because we've been doing that for a while.
Yeah.
Meters per second. Wait, how many millimeters are in 10,000?
Yeah, I did.
Yeah.
You know what? You're left out so high.
Yeah, I did. I just thought it was your Huh?
It's all calculated.
Oh,
Just remember the formula.
Okay, back down here.
That's what oh, I've been writing it all out for no reason.
Number 5. 56 millimeter diameter.
Are you see when you
Yeah, ding ding. Good. It's okay. I have the problem done. Just not right.
I'm missing.
I found that from you. The regression one is half done.
Okay.
That's a calculator regression thingy.
It's
And then I don't have the one you're absent.
Yes, I just found that in my folder. So that's
That
good.
one is.
And then you have to
mark those up.
Like I have it.
Yeah.
Thank you.
Yeah.
I have 9 now.
I completed the
I asked
rest of
for
it,
something.
so
Colt, they're all wrong.
you did them all wrong.
you locked me in a room.
Yeah, somehow, I don't know.
I did them all right.
Nothing.
Well, I got them all wrong.
I did them all right.
And I've been following my notes.
Alright, so it's once the linear speed
Eli, Jonathan, and Isaiah.
in miles
Or
per
push one out
hour.
there.
How much would be?
You started with angular.
That's not Jonathan, squat. 3.5.
Oh, that is angular. 2 pi times 3 is
Levi's just
Levi.
a lot
Levi
of weight,
weighs me, bro. Levi's.
and Isaiah's
That's my
like
velocity.
going hard is what somebody said. He's been to every single one.
So you need to take this
So, like,
answer, which is in inches per second. So 459 inches per second. And then convert that to miles per hour. So,
Man, I'm smart.
yeah, you, I mean, you would have done this part.
I would say unless what
This one, let's see, so 56 diameter, so 28
She's here,
millimeters.
you've never played before. She doesn't care.
I'm gonna see if I got this one for a second.
So all that is that
Okay.
in millimeters per minute. 60 minutes
Miss
is,
B is fine with Olivia, and Miss B doesn't like me.
so we can go.
Miss P doesn't like you because you're mean to her.
I am not mean to Miss
You're
B.
mean to everybody.
No, I'm
Yeah,
not.
you're
Tells
Joe?
how many.
You don't tell it. He doesn't like you.
So you gotta make sure you have to read it right?
Who said that?
Joe himself.
And then you have
Yes, it
millimeters.
is.
So millimeters cancel the
Probably
numbers.
just crazy doesn't like
So that is a little bit weird.
Yeah.
Okay.
Yeah.
So that was all that.
Joe's a G.
Just making sure
I love
you
Joe.
get it.
He's not
So this is that
You like
number
Susan?
divided by 60 and also
Take your
divided by
You
1,000.
seem like a good
Okay.
kid.
Very
I
good.
called him a good boy twice.
You didn't do nothing to
I'm
me.
just circling what we're
Yeah,
diving
you didn't
into.
hear that when you, in fact, you didn't hear that at all. Okay.
Good.
What?
Good to take that.
Joe doesn't like
Apparently
kids.
Joe doesn't like me.
Yeah, cool. Kind of like.
I think it's because you're almost too friendly.
You're too friendly to Joe. He's not like my grandpa. You can't just talk about when you're at my birthday.
No. It's like James was like patting him on the shoulder and stuff.
I did not touch Joe.
Pat him.
I did not. I was like touching old guy.
When we were walking past the four-wheeler, you just had gotten done saying that to me when I was showing you the cameras. You grabbed onto his shoulder while you passed him, and you looked at him. I did not. They did. You even mentioned that. Yes. That's fine.
I would just make the suggestion
Like
to
that.
say, this is.
Oh, but add the
measurements,
units.
centimeters, and not in 1 minute. And make sure that when you're done, you end up with centimeters per minute, which is what we want.
Wyatt wasn't going to. He likes his power. Okay.
Steve said.
Right, same thing.
Don't worry, he used to me too.
I did not like converting.
Converting is hard. It takes a while to.
You know what I did?
Yeah.
I thought I was.
You'll get it. This is actually really pretty good exercise. So linear and angular velocity actually has a lot to do in engineering when we have gears, like cogs.
So friendly to him.
And so if you have like a belt, like pulleys and stuff, when you have pulleys, they got a little gear and a big gear, and they're connected by a pulley. You know, one is spinning faster than the other,
No,
because
I'm
it's bigger
asking
or
questions.
smaller, or smaller ones will spin faster. And so this actually, knowing your
I'm usually
angular versus linear speeds,
Yeah,
they
you
have
used
the
to be there
same
by
linear
myself.
speed, but this one
because
is
I get
spinning a lot
called
faster.
random
So the
side
angular
quests by my
speed.
dad. He's like, comes out
Right, and so you can actually use this stuff to figure out how fast gears can spin.
Why would you go with
Okay.
him? He was like, oh, you should come bake these muffins at my house.
A lot harder
So I had something to do. I wouldn't break on the couch.
Look at crack.
Yeah, everyone else is so hard.
Talk.
Yeah.
Break on the couch.
And not, but
Dude, sometimes he's talking so fast, I just cannot understand it. Really? Hey, he doesn't even have that heavy of an accent. No, he just talks so fast with you.
Very cool, man.
This one? Did you find it? Yeah, Miss Good, I got them all right.
Oh, you read.
Don't fall.
9 minutes to finish math and study for
You're gonna say that number right.
I'm missing one from you. Just yesterday, but I don't know.
yeah, that's the one.
Yeah.
And then I have to finish this one.
Yeah, alright. Alright, so this was 12 inches. Permanent, good. And then we wanted it in miles per hour, so 60 minutes is 1 hour, good. And then miles of inches, so you have inches in a foot, and foot. Okay, great. So multiply those together. Divide by 12, divide by 53.
Oh, yeah. Tricky with math. Did she tell you that? No. I talked to her for like what? No reason. I'll tell you later. I only talked to her for like 5 seconds because I went inside.
Oh, really?
How did you have my
Yeah, yeah. So I'm missing a couple of them. Regression, number 12, and then homework 1.
Hey, oh, right. You started working on that whole thing.
What are you working on?
Oh, yeah. Same thing.
No, I know.
I'm pretty sure I've done pretty good on everything except the double mags. As you know, they are the beta of my existence.
Yes.
Get them right.
Because I feel like I get them right and then I get it wrong and then I get pressure and then it's wrong and then I continue to get it wrong because I'm
Well, I hate coffee. I only drink cold brew.
Oh.